Hi everyone, thanks for joining EJ Academy today and choosing this video to watch. So in this video, I wanted to explain the geometric series and go over the general form of the series and find the sum of the series and find a way to calculate to see if it is convergent or divergent, or is basically is a convergency test for geometric series. And so in the future videos, I wanted to also go over some of the examples of geometric series and test their convergency and find the sum using the concept that we're going to talk about it in this video. So let's get it started. So as you can see on the screen, I have the general form of geometric series. A geometric series is an infinite series. So because this is infinite series, because this is infinite sequence of ANs. So we have a sequence of ANs in from 1 to infinity. That's why this is infinite series. And so each term of this in geometric series is obtained by multiplying the previous term by r. For example, if you look at the third term, the first term is a, the second term is a times r. So we multiply this by r. This r is the common ratio. And then the third term is the previous term, AR times R, and so on. And here is basically a summarized form of the series. Is sigma means the summation over all the terms. And so you start from, I think should change this to n. So let me change the color. So this is n from 1 to infinity, and this a cannot be 0. The reason is that if a is 0, all the terms is going to become 0, and then the sum is going to be 0. So a cannot be 0, and so this geometric series is summarized as sigma a times r to n minus 1, n as changing from 1 to infinity. Now, if this r, the common ratio is equal to 1, let's see what happened to this series. So Sn would be a, the first term. The second term, I'm going to replace r with 1 in all the terms. So the second term is going to be a. The third term, ar squared, is going to be a again, and plus dot 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 plus a, this term here, a times r to n minus 1, is going to be a plus dot dot dot. And then if you sum all these terms, the summarized form is going to be sigma n equal 1 to infinity a, and this is going to be equal n times n. And then when you find the limit of S sub n when n approaches infinity, this is going to be limit of n times a, n approaches infinity. A is a constant. So as a result, this limit is going to be equal to plus or minus infinity. If a is a positive number, then the limit approaches, or this expression approaches positive infinity. And if a is a negative number, then the limit is going to be negative infinity. Okay, now let's try and see what happened to the series if r is not equal to 1. So if r not equal to 1, then I wanted to find the summation. So I have this Sn is equal to A plus AR plus AR squared plus AR cubed plus dot 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 plus ARn minus 1 plus dot dot dot. Now, so to do so, I'm going to multiply both sides of this equation by R. So I'm going to make a copy of this. And then, so I'm going to multiply this side, the left-hand side by R, and then the right-hand side by R. So I'm going to multiply that by R. Okay, now let me copy these two things. So I'm going to bring them down here. So this is just a copy of whatever I had above. Now, down here, let me delete this parenthesis. Okay, so down here, I'm going to use distributive property to find this multiplication. So I'm going to multiply this R by the first term, then by the second term, then by the third term, fourth term, and so on. So, so if I do so, I have A times R, then A times R is going to be AR squared. The third term is going to be R cubed, and the fourth term is going to be R to the fourth. And then this general term here is going to be R to the n's, and so on. Now, so I wanted to subtract these two terms. So I have on the left-hand side, I have Sn minus R times Sn. And on the right-hand side, I have this term up here. Let me copy this. Minus is all these terms on the second line. Okay, I'm going to put them inside the parentheses, a pair of parentheses. So, so now I'm going to distribute this negative sign. So I'm going to multiply it by the first term, second term, third term, and so on. So on the left-hand side, I'm going to rewrite that, or let me simplify this. So because I have a common I have a common factor Sn, so I'm going to factor that out. So I have 1 minus R times S sub n, and on the right-hand side, I have, so I'm going to copy the first line again. So this line. Okay. And then I'm going to have, I think I'm going to rewrite that. So I'm going to have minus A times R. This is the first term. The second term, if you bring the negatives and negative sign inside, so it's going to be negative A R squared. Third term is going to be this negative sign times this term here. So negative A R cubed. And then, so let me write another term, negative A R to the fourth, negative dot dot dot. And then, so I'm going to have minus A times R to the n minus dot dot dot. Okay, now I think I can just simplify this. So on the left-hand side, I have still 1 minus r times Sn, and on the right-hand side, so I have on the first line, I have a times r, second line is negative a times r, they cancel out, and then ar squared here, first line, negative ar squared, second line, they cancel out, and then ar cubed, first line, second line, negative ar cubed cancel out, and then I'm sure there's going to be another ar to the fourth on the first line, which is going to be canceled out with this negative ar to the fourth on the second line. And then so I have a r to n minus 1. This is going to be canceled out with this term before ar to the n in the second line. So it's going to be ar n minus 1. There is a term like this before ar to n. So this is going to be canceled out with this term. So what I'm going to be left with is this term here at the beginning and this term here at the end. So I'm going to have a minus ar to n. Now there is a common factor a here in these two, so I'm going to factor that out. So I have a times 1 minus r to n. Now I'm going to divide both sides by this 1 minus r because I'm looking for s sub n. And the reason I can do this is because r is not equal to 1, then 1 minus r is not equal to 0. So how do I know r is not equal to 1? Because up here, I assume r is not equal to 1. So if I divide both sides by this non-zero value, then I'm going to get Sn is equal to a numerator is 1 minus r to the n, denominator is 1 minus r. So this is a general formula for calculating sum of geometric series. But so we know a is a constant, is non-zero, r is not equal to 1. But if there are two cases, if r is between 1 and negative 1, in other words, if absolute value of r is less than 1, then what's going to happen? If that's the case, Sn is equal to a fraction line 1 minus r to the n 1 minus r. If I calculate the limit of this when n approaches infinity, then this term here, r to the n, is going to approach to 0. So how do I know that? We can try like a number. Let's say r is equal to 1/2. Then r or 1/2 to the power of 10 is obviously a larger number. If I increase n to 20, then 1/2 to 20 is a much smaller number, and 1/2 to the power of 30 is a much smaller number. I can calculate some of these numbers for you. So 1/2 to the 10th is going to be 9.76 times 10 to the power of negative 4. This is bigger than 1/2 to the power of 20, which is 9.53 times 10 to the power of negative 7, and 1/2 to the power of 30 is 9.31 times 10 to the power of negative 10. You see, as I increase n, the value of r to n it just approaches 0. So in that case, this sum is going to be equal to a fraction line 1 minus 0 divided by 1 minus r. So this is equal to a divided by 1 minus r. So a and r are just constant numbers. So this Sn is going to approach a number. And this means that this is convergent. Convergent. So if r is less than equal -1, or if r is greater than 1, then this series is divergent. And the reason is that, so this Sn, the limit of Sn n approaches infinity equal the limit of a times 1 minus r to n divided by 1 minus r n approaches infinity. This term here is going to go to infinity. That's why this limit is going to become infinity. And for that reason, this is divergent. It doesn't have any sum. So that's it for this video. In this video, to recap, I introduced general form of a geometric series for you, and I found the sum of the series, and you can use this sum to test to see if the series is convergent or divergent, and it depends actually on the value of r, which is the common ratio. If you have any questions, please leave it in the comment section below this video, and I get back to you as soon as I can. And don't forget to watch future videos. I'm going to go over a few examples of geometric series and use this concept here in those examples. And if this video helped you to understand better, so please hit the like button. Also, don't forget to subscribe to our channel and hit the notification bell for future videos. Till next video, bye everyone.